sent out an email and you all responded, which was wonderful. This is one of 3 engineering classes here at Portland High School. It's part of a national nonprofit called Project Lead the Way. I wear my Project Lead the Way shirt today, and it provides engineering curriculum to high schools. It's a nationwide nonprofit, very highly esteemed, and this is its 3rd year at Portland High School, and it's going great. I love teaching the classes, and I've got tons of great feedback from students about it. And I've got a great group of students here. So, let's just jump right in. We have until 9:15, that's when the class ends. So if you would just introduce yourself, say where you work, and just a brief 1 or 2 minute description of your projects. That way we have lots of time for the students to sit with you and really get into, interactions. Okay? Start with you?
Oh, jeez. Okay. We're going to have to start with you. My name is Heather. I work for Lewis Berger, which is a transportation consulting firm. What we do is we work with a client, so we get told what the client wants, whether it's a bridge. I'm a structural engineer, so I work on mostly bridges. Someone like the Maine DOT would tell us that they need a bridge built, say, like the Casco Bay Bridge. We would then design the bridge and we would create a set of plans, which I didn't bring any plans, but you have some. And the plans would then go to the contractor and out to bid, and whoever has the lowest price would come back with how they think that they can build your set of plans, and then they would go out and build it. So we're kind of the middleman that designs and sends the plans to someone. I also went to Maine for 6 years. I did 4 years of undergrad in civil engineering, which is an awesome program, and then I got my master's in structural engineering also.
Well, thank you. So, Heather.
I'm Val. I'm actually not working at the moment, but when I was working, I was a software quality assurance engineer. So I tested software, I tested websites to make sure that they worked, so that when a customer used it, everything went correctly and they didn't get overbilled and all of their data was in there properly. I worked for a company that connected hiring managers with recruiters, with headhunters, and connected them. And so basically you have to go through and make sure that everything's getting entered and saved properly, that all the data goes to both sides of the customers correctly, that any charges go correctly to a credit card. Credit cards aren't saved, so you have to make sure that happens properly. What else? My background is computer science, but you don't necessarily have to be a computer scientist to do quality assurance. It's really sort of just being smart.
Great, thank you.
Hi, I'm Amy. I'm a bridge engineer like Heather as well. I work for HMTV. We design a lot of the bridges on the Maine Turnpike and some bridges for the Maine Department of Transportation. I went to school in Buffalo and got my master's in Illinois. I also volunteer with an organization called Bridges Prosperity that builds footbridges in developing countries. And that's more like hands-on actual constructing the bridges, and I have both in charge of that.
Thank you.
Hi, I'm Ron Brown. I'm a RN graduate, and I then did graduate work at Tufts University and Queen's University in Ontario. And I'm an electrical engineer. That's what the degree says. More accurately, I'm a systems engineer. And so in the electrical area, and especially in the communications area, my expertise is I can look at the whole thing, like the whole telephone company, the whole corporate network or something like that. And I have other people who know all the details of all the little bits and pieces who work with me. Now, I haven't done too much of that kind of work recently. Most of my work today is I work as an expert for lawyers, enforcing patents, defending patents. You may have heard about Apple and Samsung being at each other's throats. I'm not involved in that one, but that's a common one that everybody talks about. I do contracts work. People dispute what contracts have to say, and not just from a legal standpoint, from a but from an engineering standpoint, I get involved in that, and I got involved in the antitrust suit with between the European Union and Microsoft. I was working for the European Union at the time. The types of work I do vary, though. A lot of that work isn't the kind of engineering work that you learn in college. It's judgment work. I do a lot of statistical analysis work. Later, I took a course in how to design statistical experiments, and boy, was that eye-opening for me. And I'm still learning too. And if you go into engineering, you'll always be learning. If you're not, you're out of it. But it's fun. I've enjoyed it. Next.
Hi, my name's Emily. I graduated from Maine, and I have a mechanical engineering degree. I'm dual licensed in mechanical and fire protection engineering. I work at Colby Company Engineering downtown, and we design buildings mostly. And we have, people we've got civil, structural, electrical, mechanical engineers, basically all the disciplines you'd need to design a building from the ground up. And we have, architects who also work, with the exterior and the interior design. And so my piece as a mechanical and fire protection engineer is I'm mostly dealing with the heating, ventilating, air conditioning, sprinkler, fire alarm systems. And, the importance of these systems, and the interesting part of the work is, it affects energy, health, safety. It's about reducing the amount of energy that a building consumes. It's about keeping people safe and allowing them to exit a building safely if there's a fire. It's keeping people healthy, with bringing in enough fresh air, preventing, growth of mold and, buildup of hazardous chemicals in the environment. So that's what I do.
Good morning, my name is Mason Ide, and I'm a mechanical and textile engineer by discipline. I have over 45 years in the engineering profession. I've enjoyed it. I've had a lot of fun at it. It's cyclical, but I've designed things from concept. If a person comes up and say, well, I've got this neat idea, and what a lot of things that I do is I help people if they have an idea after I ask them, well, who besides you and your immediate family is going to buy it? Because you have to do market research. But then we get into and make a concept model and say, well, how does this work? And we'll use different ways of just making things to try them out. I've always liked working with my hands and gone through, there's a whole lot of awesome tools that we have to work with today. And I've worked with, done a level gauging system for super tankers. I've worked for an industrial mixing company that you may be familiar with your home egg beater type of thing, which mixes cake mix and etc. This company, and we had those mixes would have like a 3 horsepower motor, as opposed to one on your home mixer is probably about an 1/8 of a horsepower, all the way up to 750, 800 horsepower mixing batch, depending on what the recipe is. And I've had an opportunity to travel quite a few different countries for companies I've worked for.
Thank you. So one thing that I heard that I forgot to put on the sheets is that a lot of engineering jobs that you can have, and I don't know if there's possible to have an engineering job that doesn't, but one thing that you can ask is how does what you do impact the world? How do you kind of make a difference in the world? That's another thing that you can ask. Because I think that they all can probably answer that pretty well.
To present the information to you in a way that you can understand it. So that's really what communications is about. And also then the manipulation, the processing of the information and things like that. As I said in my introduction, I look at the whole thing. If you're, in Portland, Maine, and you're trying to work with somebody in Singapore, and you may be doing that as engineers because people have their engineers spread all over the world, you need to be able to communicate effectively. That means language, that means good voice communications, it means rapid data communications, the ability to transfer the diagrams or the other information in a good form. All of that's part of the puzzle. So it's not just this little thing that we have in our pocket or that. It's a lot more than that. If I don't speak Chinese. If I have one of these and somebody in China has one of these, we're in trouble unless that person speaks English. Yeah. So I get into all of that kind of stuff. But earlier, now you can get telephone service, telecommunication service from Time Warner and GWI and all those people. Well before you were born, there was only one phone company in town. I built the first competitor. It was scary, but scary is fun to me. Maybe I'm nuts. I enjoy the challenge. Hopefully I answered your question.
Yes.
This is another bridge I worked on. I know they kind of all look the same, but these are the piers that support the bridge. So it's holding the bridge up like this, but it's a different bridge. So there's a lot that goes into it. There's a lot of, I just see a lot of plans. But this is all what the contractor uses. First they have to decide how much it's going to cost, and then they bid on it, and then if they're the winning bid, then they have to go out and construct it. So the contractors are really the hands-on people that build the bridges, and this is like a mini version of that. When I volunteer with this, I'm the contractor. But basically, what we try to, the whole focus is to train the community to build the bridges so that they can continue doing this once we leave.
How long does it usually take for you guys to make
These kind of bridges or these guys? Something like this could take about a year to construct, depending on the complexity of it. Something like this usually just takes 2 months. This is very hands-on, and all the excavation, you're in kind of a remote area, so all the excavation is done by hand shoveling, and that's why it takes longer. In these city bridges, you see the construction equipment when you're driving down the road and everything. They can go in and bang this out a lot quicker than something like this. So it just depends on the type of bridge, where it's located. If it's remote, sometimes that makes it take longer. So. But usually highway bridges are they can be done within a year, start to finish.
What was one of the hardest things about being a computer engineer?
I think keeping up with technology. So I haven't worked for a few years because I've got a 3-year-old, and basically the cell phones have taken off since I stopped working. One of the ways to do that, sort of like I just suggested, is to go and do things on my own. That a lot of companies will keep you taking classes and learning about stuff, but the more you can do on your own, the more they're going to want to keep you. Because they, of course, don't want to pay for schooling. So if you can use it on your own, that's really important. Otherwise, dealing with people can be one of the hardest things, because the software is really easy. That's not going to argue with you. But if you have a boss or a coworker who's hard to work with, that's going to be something you really have to look at, and that just takes doing it.
What do you like about your job? I kind of like that my job, I have times in the day when I'm just sitting at my desk, it's kind of just quiet and I'm just kind of doing my thing. And then I have other times a day when I'm sitting around a table and having meetings and working with people. But it's I like the balance of that. I like the ability to just kind of zone out, listen to some music and just do my work. but like I wouldn't want to work by myself. Like I like having the social environment of like talking to people and solving problems as a team.
Is it tiring?
I mean, not really. Like it's for me, like the first couple of years after I got out of school, it was hard because I was learning so much. There's a really steep learning curve. Like when you get out of school and you're trying to learn sort of like your trade or your area of expertise. So I found it a little more tiring when I was going through that, but I've been doing it for over 10 years now. So I've got, a lot of it under my belt and I've got a good foundation. So it's not tiring. I mean, sometimes I'll go out to a job site and I might be there for, hours, kind of like, climbing up ladders, like inspecting docks, crawling under things. So days like that when I'm like running around a lot, I'll be like fairly beat at the end of the day. But it's not so much the physical, it's also the mental. You're inside an existing building and you're trying to figure out how does this building come together. And it's such a like mental exercise, like chasing all the pipes, chasing all the ducts. It can be a little tiring. But good though, in a good way.
This is, okay, that's just a regular screw. It's in the fasteners is general classifications without getting into all the nitty-gritty details. This happens to be a circuit breaker that in electrical devices, circuit breakers are used so that if too much current is going through it, it can burn up the motor or the device. Well, this one was made with a bimetal, and as the bimetal heats up, it will break contact. So, it's basically a switch.
Yeah.
It's a form of automatic switch. So that's, I worked with a company that made those for a while.
So is that what this is for? If you pull?
Yeah, that'd be basically a wire connected to each end.
Okay.
It's basically like a switch, like a light switch, and just on a smaller, category, so to speak. And then, so like to say, this particular one, this was a cutaway of the valve that I worked on. Part of what I took out, that this is what was called the carriage assembly, because we gave it that name because it carried, there's two valves within this housing area that would, in one portion or the other, one would shut off flow to one port and allow it to go to the other port. So this one would, when it was driven by this electric motor in here, permanent magnet electric motor, that would drive this, and it would go to a certain point and then stop, and then we had a little clutch mechanism, so when it overdrives, it would just keep clicking, so that we knew.
So I went to Maine for 4 years, and I started working at the Advanced Structures and Composites Lab, which is a really good place to go visit if you guys are up in Orono. And so I worked for a grad student when I was an undergrad, so I would do testing, and I got to test carbon fiber, which is this outer shell material. And I got to like put it in the machine, and then I pulled it in tension to see what the load capacity was. So the carbon fiber, the samples that I was testing was holding like 14,000 pounds, which is like 7 Honda Civics basically, which is pretty impressive. So then, because I was already working at the center, I got an assistantship, so I got to work as a grad student, so I had grad school paid for, and they paid me to work at the lab, so I got to do testing and research for UMaine, and it was on this bridge and a backpack stuff, which is pretty exciting. So I strongly suggest UMaine. It's pretty awesome.
Do you know any colleges like in Michigan?
For engineering, I think Michigan State and the other one, University of Michigan both have good programs. And Lawrence Tech, my cousin works for Lawrence Tech, and he got his architecture degree there, or his master's in architecture there. But he, I think that's where he went, was Lawrence Tech, so I would look into them. Or engineer, I think they do engineering, because a lot of the research that I did, I had to use Lawrence Tech's, like one of their professors' work and reference it, so.
Guys, there's only about 5 minutes left of the class, so I'll just ask you to take one more minute, finish up your conversation.
Thank you so much. I need to know about like programs that you would suggest for like kids who are getting interested in engineering or anything.
I know that there's, like UMaine has engineering camps, and then there's also e-weeks, so like look in the newspaper, and there's the engineering expo. Every other year it switches, so I think last year it was at USM, so this year, so it's in like March, and you can go and and it has displays from a lot of organizations, a lot of companies, so you can go and see. It's basically this, but more in depth with you, and it's at the university, so you have kids, like college students showing you, like they have the robotics stuff out, they have, we make concrete hands, so you mix your own concrete and then you make, like you put it in a plastic glove and you make the hands, and it's for all ages too, so there's like little kids there, and then there's also high school students that are looking to get into engineering.